All right, let's just give everyone a few minutes to join. Okay, we're going to still give people some time to join, but we can go ahead and get started. Good morning. Thank you so much for joining today's Steel Connect Classroom webinar. We launched this series to help train and educate personnel on the plant floor, distributors, and equipment manufacturers. This monthly webinar series focuses on reliability, maintenance, and of course, proper sealing tactics. We invite experts from across the industry to join us each month to help ensure that all personnel have the skills they need for success. Today, we have our very own Chris Tindell with us. He's the Regional Business Manager for SEPCO, as well as a maintenance and reliability professional with more than 20 years of experience in reliability consulting, training, and troubleshooting equipment. Before we get started, I'm going to go over just a few housekeeping tips. So you can ask questions directly to Chris and me through the Q&A section in the panel to the right. Anytime during the webinar, we'll be able to see it, and I'll either ask your question at the end, or if it's timely, I'll ask Chris in real time. This webinar is being recorded, so you will be emailed with a link to the recording within 24 hours after this session ends, and slides will be emailed with the recording later today. So Chris, while we wait for people to hop on, could you tell us a little bit more about yourself and your experience in reliability solutions?
Sure, thank you. Yeah, I've been in reliability for over 20 years, mainly in the consulting side, looking at equipment troubleshooting in the field, focusing on vibration analysis, lubricant analysis, and so just have had an opportunity to work across multiple customer sites, multiple industries, and just learn from a lot of people along the way. Have seen some really effective reliability programs, and just met a lot of people who, again, this is just opportunities like this to share with others. I think that's the most important part of our community and reliability, is just the way that we share and help each other out in sharing knowledge, and just look forward to having an opportunity to do that today.
Awesome, Chris. Well, if you're ready, let's go ahead and jump right into the webinar. I'm going to go ahead and mute myself and turn my camera off, but if you need anything, just holler, and if our attendees need anything, you can send me a question.
All right, sounds good. Thank you. So the title of this webinar was how to track mechanical seals in your CMMS system. And what I really want to focus on is why. The agenda, we're going to cover novelty versus innovation. We'll talk about a case study and just some of the things I've picked up along the way in supporting tracking mechanical seals. But at the end of the day, the how is pretty easy. The why is, I think, the most important part. So before we jump in, there's a poll, and Anna Claire, if you can launch that. So the poll is, do you currently track your mechanical seals? Yes or no?
We're going to wait just a few seconds to give everyone a chance to answer. Okay, so we have 50% said yes and 50% said no.
Oh, wow. Okay.
Yep.
Good deal. Well, that, so tracking mechanical seals is something, it sounds 50-50. I think that that's a pretty common. I would expect something like that, but it's not only tracking from a cost perspective, but actually, I want to suggest that mechanical seals should be treated as a rotating asset, that they should be serialized and tracked. And ultimately, I want to suggest that by doing that is probably the single most important thing you could do to improve pump reliability. So that's a bold statement, but in the way that we track mechanical seals can really impact the performance of not only the seal, but the performance of our pumps. And so we'll talk some more about that as we get into the presentation. One of the things I want to consider that this is the idea of tracking a mechanical seal. Sometimes we say this is the best thing since sliced bread. What you see on your screen is actually one of the first machines that were developed for slicing loaves of bread. And what's interesting about that is the idea that ultimately became the best thing since sliced bread wasn't really accepted when it first came out on the market. So the guy that invented this machine, he focused on the how and the what of slicing bread, but no one really bought into the concept. They were very skeptical, and it basically became a novelty. It was one of those things that people were arguing that once you slice the bread, that it would become stale, that it was much harder to handle from the bakeries to the stores, and no one really bought into it. They were just as comfortable slicing their own bread at home, and so there was really no innovation that came from that. And so, unfortunately, the inventor never saw sliced bread become a common thing before he passed away. So it wasn't until Wonder Bread came along and they came to the market with telling people why they needed sliced bread. It was one of those things to where, of course, you can slice your own bread, but what they did is they painted the picture of what that did for you as a in your daily life, how much time you actually saved by having to slice bread in the morning to make sandwiches or to make toast, and just basically sold the concept as a why you should want sliced bread. And so what's interesting about that, as we talk about why you should track mechanical seals as a rotating asset, this goes back to 20 years ago. The concept, I learned it while working in an aluminum refinery. And I was working for a company that had 9 refineries, a dozen or so smelters, several mines, and we had moved to an enterprise system with our CMMS to where we were starting to organize all of our plants under one central umbrella and using one central CMMS system. So I was part of a engineering technology team that was looking at how to standardize and source materials for each location so that we could leverage buying, so that we could have consistency across similar business units. And so one of the first things that I was involved in was a project covering packing, gaskets, and mechanical seals. And so why this is important is that when you look at the picture, one of the first things that you'll notice, this is an aluminum refinery, and you'll see there's a red side and a white side. And so we're trying to standardize packing, gaskets, and mechanical seals. Just in one refinery alone, there was a direct split between the red side and the white side. And there was similarities in the processes, and there could be arguments made for what product materials should be used as far as gaskets and mechanical seals and packing goes. But for the most part, there were arguments about which suppliers and which vendors, and there's this emotional aspect to that becomes part of the argument. And so just trying to get the facility to agree from a macro level was difficult. And not only one facility, but this was duplicated across the multiple refineries and that are very similar. On top of that, when we would have a meeting within the facility, there were multiple departments. And so when representatives would show up to the meetings to discuss which products should be standardized upon, it really looked like a NASCAR driver. I mean, these guys would come in carrying sponsoring their favorite vendors, and they would have all of the vendor merchandise, the calendars and the hats, and they would show up to meetings, and it would just become an emotional argument over why they believed this supplier was better than that supplier. And so one of the things that we had to do was to step back from the emotional aspect of things and really look at the data. What is going on? What is the best mechanical seal, the best gasket material? And ultimately, we decided that the best way to do that would be to start tracking true reliability and look at the life cycle of the equipment. In the meetings, we actually several locations had vendors who had people on site that were there to support mechanical seals and gaskets and packing. And so those guys would show up to the meetings, and it was really it was like having the wolf guarding the hen house. And so really stepping back, and that's not a bad thing, having your manufacturers involved in the discussions and trying to maximize reliability. But at the end of the day, what is the data telling us? And what we found is that especially when it came to mechanical seals, gaskets were a lot easier just because those were consumable items, and we could see usage across multiple assets. We could look at the cost and the usage of the consumable parts. But when it came to mechanical seals, one of the first things we discovered was that we really had no practical way of tracking mechanical seals because they weren't consumable. They are designed to be wear components and to be replaced, but once a mechanical seal is pulled, the majority of them are reconditioned, rebuilt, and then put back into service in another application. So we were not tracking mechanical seals at the time across locations. So when we speak of locations, we're talking, let's say there's 12 pumps, and a brand new mechanical seal was installed on pump number 1. It ran for 5 years, and then it was pulled out. The pump was rebuilt, the mechanical seal was rebuilt, it went back into stores, and then it comes back out and may land in pump number 6. And then it operates for 3 years, fails, comes back out, is rebuilt, goes back into stores, ultimately shows up in pump number 3. And so trying to keep track of the rebuild history from cradle to grave of that mechanical seal was not something we could do as it being a consumable item. And that's pretty common. I think across industry, one of the things I see is that we're still treating mechanical seals as consumable parts. And that's a big deal because you're missing a lot of information, and we'll dig into how that works and why that's why that's important. But ultimately, not knowing where a mechanical seal, being able to see that mechanical seal through its complete life, you're missing the connection that could be relative to pump number 3, could be a bad actor, and you're having short mechanical seal life in pump number 3 as compared to say pump number 1. If we ran 5 years in pump 1, 3 years in pump 3, those are things that that can highlight not only is it a location issue, but is it actually a seal issue? Is the seal that's being rebuilt no longer within tolerances? It's no longer getting the maximum reliability. Another thing that you'll notice as you're going through mechanical seals tracking, you'll start seeing that certain applications will stand out. Maybe across those 12 pumps, you may have 1 or 2 pumps that are performing exceptionally well, and the balance of the rest are pretty common. Maybe you're getting 3 to 5 years out of those, but you may have a couple of pumps. You'll start finding out that that your actually mechanical seal life is exceeding that, maybe 6, 7, 8 years. Those kind of things, you can start looking at why that is happening, and using that same information, instead of just focusing on the bad actors, look at the good actors, figure out what's going right, and then duplicate that. So those are some things that we learned along the way. Now we were able to, once we started tracking this, we were able to eliminate the emotional discussion over providers and such, and we could standardize on what we were trying to accomplish, and then bring our vendors in to help support that. But this is very common. You know, one of the things that I think everyone has in common is that we all have pumps, we all have people, and we all have an environment that has to be controlled. When it comes to pumps, you know, similar to the one on the screen, mechanically, that's the easy part. That's when we look at the services and we can design the right materials for the application, the right engineered design for the application, and those are, we get repeatable results. We can predict how materials are going to function. When it comes to the other common factor, people, that's a huge variable. I mean, people, there's variability in the skill levels. People can be unpredictable. That's one of the things that we all share across every industry, whether it be an aluminum refinery, a chemical plant, or a bakery. People are very valuable. They can be, they can add tremendous value, but they can also add tremendous risk when it comes to reliability, just because emotionally people change, skill levels people change, and people move around. There's constantly a flux of people moving in and out of positions that can impact reliability. So mechanically, pumps can be predictable, people unpredictable. You know, this common factor of people, we already covered that. Then there's the factor of environment. And environment is one of those things that it can be unpredictable, but environment is actually something that can be controlled. If we understand our environment and we plan for the impacts of heat, cold, pressure, temperature, those things can be designed for, can be controlled, and so one thing to remember about environment is that environment will change over time. We have to be aware of the environment and how we've designed our equipment for environmental conditions, but understand, just like people, the environment can change. It can be a change from how we operate our equipment. Maybe we're adding more load, more temperature. We've made process adjustments. That's something that's very common. I think everybody has experienced that if you've been in a manufacturing environment for any period of time. if things change. We constantly want to push equipment to new levels, re-engineer, redesign. So keep that in mind when it comes to seal reliability. Environment and people, I think, are the two biggest factors that we have to keep tabs on. And at the end of the day, what it comes down to is how well we take our assets and our resources, the people and the environment, how well we control those will maximize our profits. That's going to maximize reliability if we have the right materials, we're doing installation and operations in the right way, and we're controlling the environment, and we're aware of all that. We're going to maximize reliability. We're going to maximize our profits. So that's the goal. And then our challenge is what happens when things go wrong? How do we identify which one of these, whether it's a material issue, whether it's an environmental control issue, or whether it's a personnel issue, what actually happened that caused us not to achieve the maximum profits that we're all after, the maximum reliability? And you know, when you're looking at a pump, there's only a handful of things that can go wrong. From a failure modes standpoint, there's really maybe half a dozen. And this is the stuff that will show up on the work order from operations. You know, you've got a pump installed in your process, and you get a work order, you show up in the morning, and they're saying, hey, the pump won't start. And so from there, there's a handful of things. It could be a blown fuse. It could be the motor had failed. It could be a bearing issue, a coupling, maybe broken coupling, broken shaft. The pump won't start. I mean, something electrical, you know, could be the issue. Another common thing that you'll see in work orders is the pump will not pump. Pump won't pump because maybe it's not pumping to the full capacity. You needed so many gallons at so many feet of head, and you're not getting that. You're maybe getting a smaller percentage, you know, 50% efficiency. That could be due to worn impellers. It could be a plug in the system. It could be a valve closed, something that's causing the pump not to meet its target efficiency. Another common one is the pump is leaking. And you know, either the pump is leaking the product because there's maybe one of four things. The pump has a hole in it, there's a gasket leaking, a pipe has a hole, or the seal is leaking. So you've got static gasketing, piping, and such. And then the part that is the most dynamic in the system is the seal. So the seal is your dynamic seal that's at the rotating shaft, and that's the most common that you'll see show up in your work orders. Then there's also pump vibrating, or pump is making noise, or the pump is hot. Those are things that we notice in changes in operations. Those are all precursors, in fact, to leaking mechanical seals. If the pump is hot or vibrating or making noise, there could be something loose, a loose fastener, a bolt foundationally, a bearing is going out. That could be due to misalignment, imbalance. There could be cavitation in the system. But those are all things that show up on work orders. And then ultimately, I would suggest that if you just went in, if you're not tracking failure modes and failure codes in your CMMS system, one easy way to see what your most prevalent issue is, failure mode wise, is to just look at your pump, your work order descriptions. What's coming in the work requests? How many of those in the work description is suggesting that there's a leak? The pump won't pump. It's making noise. It's vibrating, and you can. What I would suggest is that in most cases, you're going to find that the most dominant failure mode is leaking pump. That is what I've seen across multiple industries, taking out our pumps more than anything else. And the pump leaking is really going to dictate the life cycle of the pump. You know, once the mechanical seals begins to leak, the pump has to be removed from service, it has to be rebuilt, and the mechanical seal itself behaves like a fuse in the system. So the vibration, it may have started as a loose bolt on the foundation. It could be a misalignment. It could be a bearing related failure due to oil contamination. But before the bearing actually seizes up and the pump won't start, or the pump can't pump, in most cases, the mechanical seal is going to fail. So it's in a way, it's one of the original condition monitoring devices. So a failed mechanical seal is a clue to something else wrong in the system. And when we start looking at it like that, then we can start unpacking what is causing the mechanical seal to fail. Is it related to the location? Is it related to the seal rebuild history, materials? What has happened with our personnel as far as our practices for maybe alignment, maybe our lubrication practices? Those will all start becoming more clear as we track this information and we start looking at the failed parts. Now, I said earlier, mechanical seals are rebuilt. Those are rebuildable items. They come out of service, especially cartridge mounted seals. Once a seal fails, we reuse several of the components, the glands, and all of the holders and such. The stainless steel parts can be reused, and then we just change out seal faces, springs, elastomers, and such. So when you break a mechanical seal down, mechanical seals are parts that have spare parts. And so even though in a lot of industries we treat mechanical seals as consumable items, those mechanical seals actually go back out. They're rebuilt and put back into inventory. So there is a life cycle of that mechanical seal from when it was newly built, from the factory to the rebuilds to all of the operational information that goes on in the life of that seal. There's really only it can be boiled down into 5 major components. There's a gland that holds everything together, a stator, which is a stationary sealing face, a rotary seal face, and then a spring mechanism to keep those together and affect the seal. And then there's secondary static seals that seal along the gland, the rotating shaft, and the housing itself. So if we become more complicated and we move from a single seal to a dual seal, basically you just have an inside and an outside seal. So you've got two, double the same components, but it's really that easy. One of the things about mechanical seals, those failure points, there's only 4 points of failure: the static seals, the gland gaskets, the faces, or the springs. And when you have a rotating component, just like a bearing, you can cut a bearing open after it's failed, and you can look at the wear tracks, and you can look at the different components of a roller bearing, for instance. You can start identifying, was there a abnormal load? Was it overloaded? Was it misaligned? Is the wear track crossing at an angle? Is there anything touching that rotaries and stationaries that shouldn't? The same goes for mechanical seals, and these parts tell a story. And so how long should a seal last? Really, when a seal comes out of service, you can look at the failed components and understand from that what the contributing mechanisms are to causing that failure. You can document that to the asset location, and from there you can determine whether if you have a misalignment issue, maybe it's in the way that the couplings are aligned. Maybe that misalignment is coming from pipe strain or something in the foundation, maybe a soft foot condition, something that's causing the stationary and rotary components to not be parallel. and not be squared up together. So, one of the things, I mentioned wear tracks. Just by looking at mechanical seal faces, we can see if there's a normal pattern, if there's an abnormal, like a very narrow wear track or a wide wear track, to show if there's any kind of movement of the two components that's abnormal. Is there intermittent wear patterns? Maybe no visible wear pattern. We just had one the other day that was like that. That's just pointed to the spring mechanism wasn't loading up on a seal. Uneven wear patterns showing something that's out of alignment, or an imbalance, or something that's causing maybe a wide pattern. But the evidence is there, and that's the thing to stress. To really maximize mechanical seal life, we need to understand what our failure modes are, and then from there we can assign that to maybe a mechanical issue, an environmental issue, or a environmental control issue. Because with a mechanical seal, it's all about controlling the environment that seal is in, so that it stays clean and lubricated as much as possible. That's how you're going to maximize the life. And then there is the human element of it that I would argue is the most important, because we as humans can impact in a positive or negative way the life of our seals, just in how we perform our jobs, how we operate the equipment. Maybe it's an operating process that needs to be changed, or how we're doing installations and such like that. So more evidence of edge chipping or flaking, peeling, thermally induced fractures, mechanical fractures. All of this is evident anytime we have a component that is making contact, a bearing, a seal, such like that. The evidence is all over the place. So those are opportunities for us. So if you're not tracking this kind of information, you're missing opportunities. You're missing opportunities to really quantify where the issues are, and make adjustments to improve reliability. Elastomers are also another area that can, from the static standpoint, that can fail. They can be cut, nicked, hard, cracked, extruded, compression set, could be swollen due to chemical attack. All of those things, just looking at the elastomers and looking how they change over time. Was there a static leak path that was formed over time with the mechanical seal? Those are things that's more evidence that we can take advantage of. And ultimately, where do defects come from? From any machine. If we're purchasing a pump, there's the design phase, the purchasing, the storage, the handling and installation, how we operate and how we maintain the equipment. All of that comes together to find the reliability of the asset. Anywhere along the way, there's a human element involved in that. So in the design side, these are just rough numbers coming from industrial, from some of the tracking that we've done. 22% in this case caused by improper design and undocumented modifications or changes. Those are things that come along where someone just makes a change in design, and it's not controlled through a management of change process, or we're not really looking at what that design is how it's going to be, or how compatible it'll be with our process, with our environment, with our practices. And so design can certainly be an issue. Purchasing can be an issue. Even as far as cost, we focus a lot on, especially when it comes to mechanical seals, just reducing cost. It's a maintenance item. It's a line item that's generally high. And so companies will come in and they'll say, hey, we're going to target a 10% reduction in cost 20% reduction in cost in this category. And sometimes that is reflected in design, and it can ultimately impact the process, and there's other hidden costs that can be that can show up because of those changes. And then just delivery commitments, pushing things through can lead to mistakes in product specifications. Storage and handling is always an issue, installation, and so you can see how these all fit together. But ultimately, what we want to do is we want to find out where to focus. Where is our biggest problems? What should we focus on first, second, third? And along the way, it really comes down to we're dealing with wear parts that are designed to wear out. They're the sacrificial parts from a rotating shaft and a stationary pump. We have a mechanical seal that bridges that gap, and it's designed to minimize friction as much as possible, to affect a seal and maintain whatever product media that we're moving, to keep that in the pump, keep that off the ground, and ultimately understanding that we have a stationary component and a rotating component that is causing wear. We want to maximize that, and we want to control the corrosion, the erosion, the fatigue and overload, all of the mechanical things that the mechanisms that will cause that mechanical seal to fail. And from the design, the purchase, the storage and handling, the installation, operations, and maintenance side of the life of that seal and how it is processed in and out of service, those each step along the way, we need to consider the mechanisms. And if we look at the failed parts, those will point to what was the mode and the mechanism, and at what stage did we introduce that? What can we do to improve the reliability? So having that information becomes critical to pump reliability. And ultimately, all that being said, I think that if you take the challenge, look at your CMMS history, even if you're not tracking mechanical seals now, a common place to start. One of the things that there's two things you can do today. Number one, you can do a quick survey of all of your equipment. Let's say you have 100 pumps, and then you can look at how many mechanical seals that you actually have in your warehouse. What is your buying history? Let's say you bought 100 mechanical seals in a year's time, and you had 100 pumps. You're basically replacing each one of those in a annual cycle. And so that's a quick way to start to see where you're at. What is your life cycle? You can ask your seal provider. They should be able to tell you. They should be able to say, here's how many mechanical seals we provide to you, and here is your usage. And then out of those 100 pumps, you would have to do a quick survey to find out, does every one of the 100 pumps have a mechanical seal? What percentage have mechanical seals versus packing? So that's just a quick entry level way to figure out what is your current life cycle. That doesn't give you the asset location yet, but it is a quick way to do it. And then also, just in your CMMS system, there is a ton of information. I suggested looking at the work request descriptions. Operations will tell you what is it that they're unhappy with. So when they send in a work request, they're not necessarily telling you what's going wrong in any detail, but they're telling you the pump won't start or the pump is leaking. And from those descriptions, you can quickly do a query. One of the simple functions in Excel is to be able to just do a search across all of the work order descriptions and label all of the ones that have the word leak, and all of the ones that's pump won't pump, or things like that. And you can start categorizing in your work order history where those problems exist. And then ultimately, Again, those are two steps in the right direction, but serializing your mechanical seals and tracking those seals through the life cycle of the seal and looking at where they're going in and out of locations, how often they're rebuilt, will answer the question. I think you'll be surprised to see there is on a rebuild process, if what we saw, and I've seen this across multiple industries, that a new seal will last longer than a rebuild seal. That rebuild seal, there's some loss in performance. And if you're tracking that across locations, you'll see that. You'll see, and you'll start seeing a drop in useful life of the mechanical seal as it goes through multiple rebuilds. I would suggest that that's something that's that you could prove through this process. So, and that brings us to another poll. I think this is the last poll.
Yes.
All right. Anna Claire, if you'll launch that, the poll question is, how do you classify your mechanical seals? Are they rotating assets or consumable parts?
Great. We'll give everyone just a few more seconds to get their answers in. Okay. Looks like we have all those responses. Looks like everyone said consumable part.
Yeah, very common, very common. So, all right. That is the presentation. Again, I would suggest that to maximize pump reliability, mechanical seals must be treated as a rotating asset. There's so many benefits to doing that. It's easy to say. It's not a complicated process, but for anyone who has, tracked motors or pumps as rotating assets, you understand that when a pump is rebuilt or a motor is rebuilt, it has to be serialized and then it has to be moved within your CMMS system. So there is extra steps. So it's something that people don't do lightly. We typically treat them as consumable items because we don't want to add another level of in our process and any other, we want to keep things simple. But I would argue that there is a tremendous amount of information that can point us in a direction to understand, make decisions about our rebuild process, to understand and track the useful life of that mechanical seal, to see if there's something that is wrong with the seal through the rebuild process, if there's something more functionally wrong with a location, and then ultimately being able to track failure reports and looking at the failure mechanisms will help point us in a direction and help understand how to address the people aspect of things. Training is a critical part of that, and ultimately, there's a limited amount of training dollars. It helps us focus those dollars and those resources in areas that can get the most bang for the buck, the most impact. Any questions?
No, the questions that we got, you have answered. Well, one question that I believe you did touch on that you might want to just answer here at the very end is, should you conduct failure analysis on disposable seals? You kind of touched on that earlier, but maybe just wrap it up here.
Sure. Yeah. Even if you are truly consuming seals, and there are cases where people just buy new seals, or maybe even just a component seal. There's tremendous value in doing a failure analysis, understanding what was the primary contributor to the failure, what mechanisms, and then ultimately that can help you with designing just in our processes or in our materials ways to correct that and maximize the life. So
perfect.
Sorry.
Well, that was really the main question we had. Chris, thank you so much for your time, and thank you to everyone who joined us today. Make sure that you register for next month's webinar. It's free, as all of our Steel Connect classroom webinars are. In our April webinar, you're going to be able to learn how wearable hands-free devices facilitate work, troubleshooting, and repairs remotely. So thank you, everyone. Thank you, Chris. And we just hope you all have a wonderful day. And if you have any questions, please don't hesitate to reach out to Chris directly. You can find his email and his phone on this slide. So thank you, everyone. Thank you so much.
Thank you.